Welcome and thank you for standing by. Participants are in a listen-only mode until any of the question and answer session opportunities today. At those times, you may press star one on your touch-tone phone if you'd like to ask a question. Today's event is being recorded. If you have any objections, please disconnect. And I'd like to turn it over to your host, Ms. Catherine Hambleton, and thank you very much, ma'am. You may begin.
Thank you very much. Good afternoon. I'm Catherine Hambleton from NASA's Office of Communications. Thank you for joining us today to talk with our experts about science investigations, technology demonstrations, and commercial products launching on Northrop Grumman's next commercial resupply mission to the International Space Station. In less than a week, Northrop Grumman will launch its 14th cargo mission with the company's Cygnus spacecraft loaded with nearly 8,000 pounds of supplies and payloads. Here to talk with us today about some of the research and technology demonstrations and commercial payloads are Carl Hassenstein of the University of Lafayette and Dave Reed of TechShot, who will discuss the Plant Habitat O2 investigation, which will study how radishes grow in space to prepare for feeding future crews on deep space missions. Yusuf Erkul of Kernel Biologics, who will discuss the OncoSelectors investigation, which leverages microgravity to identify targeted cancer therapies. Jim Fuller of Collins Aerospace and Melissa McKinley of NASA, who will discuss the Universal Waste Management System, a compact and reliable space toilet that will be used on the space station and on the Artemis II mission. Carlos Cabrera and Camila Morales Navas of the University of Puerto Rico at Rio Piedras in San Juan, who will discuss the ammonia electrooxidation investigation, which studies a potential innovative water recovery system. Felix Lejeunesse and Paul Raphael of Felix and Paul Studios and Jonathan Woods of Time Studios, who will discuss the ISS Experience EVA camera, which will be used to film a spacewalk and Earth views in cinematic 360-degree virtual reality. Phil McAllister of Commercial Spaceflight Development at NASA, and Stéphane Lafaveri, the Group President of the Estée Lauder Companies and Global Brand President at Estée Lauder, who will discuss the company's new advanced repair serum that will be photographed in the space station's iconic cupola window as part of NASA's efforts to establish business activities at the space station and develop a robust low Earth orbit economy. Our speakers will provide a brief overview of the research and their payload, and we will open the lines for a few questions after each speaker. If we have time at the end, we'll open up lines again for additional questions. Your phones are on mute now. To get into the queue for questions at any time, you can press star one on your phone, and the operator will call on you when we get to questions and open your mic so that you can ask your question. We ask that you please stick to one question, and if we have time, we'll allow reporters to ask a second question. About an hour after we conclude, you can listen to a replay of this teleconference by dialing toll-free 800-342-8825. That's 800-342-8825. Now we will hear from David Brady, Associate Program Scientist for the International Space Station Program at NASA's Johnson Space Center in Houston, for an overview of some of the science going up on this mission. Over to you, David.
Thanks, Catherine. And I want to thank you all, echo what Catherine said by thanking you all for joining us today. Humanity faces many challenges today, and I'm proud to be part of a community that accepts challenges on a regular basis, that turns problems into solutions and opportunities into reality. Today, you're going to hear from representatives of projects flying on the Northrop Grumman CRS-14 mission. Leaders in their field, they will describe a variety of topics that result in solutions, innovations, and new opportunities to benefit humanity in the fields of medicine, space exploration, agriculture, waste management, water reclamation, energy, human engagement, and economics. You know, when I was trying to seek a unifying message for today's event, this is what came to mind. The human body and spirit is complex, both for individuals and for society as a whole. Supporting it both on Earth and in space is challenging for both short-term as well as its long-term needs. Today's topics will demonstrate how we tackle the challenges associated with doing this, including the value of allowing humans to experience extraordinary environments for themselves. In addition, history has demonstrated the importance of economic development to human exploration. I'm very excited that today you'll get to hear from the folks who will make this happen. Are there any questions from social media or any other sources?
And yes, as David mentioned, we are taking questions via social media this time around using the hashtag AskNASA for those listening online. We actually do have one question from social. We'll start there.
Hello, I have a question from Twitter. Natalie asks, are the supplies on board going to be put to use by the Expedition 64 crew, or will the Expedition 63 crew be able to start implementing the new science?
Actually, the answer is both. It depends on how we schedule the science. Chris Cassidy, as you may know, is already up there. And we will also, in addition to having Kate Rubins going up on the next expedition, we will also have the Crew 1 crew up there pretty soon. So we fly the cargo so that it is ready to do the research as soon as the researchers are ready to do their research on orbit. And then we do our scheduling with the crew across the expeditions to support that research whenever time and resources permit. Good question, and thank you for it.
Thanks, David. And just a reminder, you can press star 1 at any time to be put into the question queue. And it looks like we do have a question. Operator will take the first question.
Thank you. Our question now is from Gina Sansiri of ABC News. Your line is open.
I'm not sure who can take this, but what's new and improved about the toilet going up?
And Gina, actually, we're going to have each of our speakers talk about their investigations, and we'll pause for questions after each of the speakers. So if you can hold on to your question and jump back into the queue when we talk about the Universal Waste Management System, we'll absolutely answer that question. All right. So now we'll actually go to Carl Hassenstein and Dave Reed. Carl is a professor of biology at the University of Lafayette and the principal investigator for Plant Habitats O2. David is the Florida Operations Director for TechShots, Inc., an implementation partner for the ISS U.S. National Lab. He is an engineer and the current manager for NASA's Advanced Plant Habitats. Plant Habitat O2 will study how radishes grow in space to prepare for feeding future crew on deep space missions. Dave, can you start us off?
Yes, good afternoon. Thank you. The Advanced Plant Habitat is the largest, most complex plant growth facility that's currently on the space station. It brings to space the ability to conduct experiments with precise control of the growing conditions like illumination, air quality, and soil moisture, the sorts of things that you think about when you think about what's important to growing plants on Earth. My company manages the plant habitat, sustaining engineering, and operations for NASA. We are really excited to begin supporting experiments using large plants such as radishes, that we'll hear about in just a moment from the principal investigator. And in the not-too-distant future, other large plants such as peppers or tomatoes that will be coming in the next couple of years. So with that, enough about Plant Habitat, the facility. I'd like to turn over to the real exciting part, which is the radish investigation, and Dr. Hassenstein.
Okay, so as you have heard, we are trying to cultivate radishes. And this may seem like a trivial prospect, but it is actually the transition from basic plant biology in space to a production system. And as you can imagine, the transition is complicated because we have little to no data to rely on as to how plants respond to different conditions in their environment. And these conditions include many aspects, including microgravity and the resulting steps like the lack of buoyancy. The Advanced Plant Habitat is able to provide most, hopefully all of these constraints in a controllable fashion. What we need to look for is then a comparison between the preparation that went on extensively in ground studies so that we know how this instrument actually performs and how to implement and optimize this for space experiments. The first and foremost parameter to study is, of course, the size and the quality of the radishes that we will harvest after a growth period of 27 days. And that is also important because radishes grow quickly, and so they allow us to assess their conditions and responses to microgravity, altered buoyancy, and so forth very quickly. One of the parameters we intend to analyze concerns the mineral content, that is to say, the quality of the radishes that we grow in space. Do they provide the same health benefits as we know they provide on Earth? An offshoot of this is something that is not really studied, but I would like to point it out here. We don't know if the flavor perception and development of flavorful components is the same in space as it is on the ground. So this is an interesting future question. We will investigate how the size of the radishes compares to the size of the leaves. We intend to look at water management problems. As you know, buoyancy is not prevalent in space, so we have to use artificial means to provide water to plants in a measurable way without drowning them. And this requires the removal of water that is transpired through the leaf surface. In addition to that, we need to know if the uptake of nutrients, that is to say, the amount of fertilizer that is consumed or required by these plants, compares to that for ground studies. Another important parameter that is also going to be investigated concerns the light composition. We know from ground studies that blue light facilitates or encourages the formation of the radish bulb itself, and it reduces the surface area of leaves. Is that the same in space? This is one of the questions we intend to answer. Throughout the time period of 27 days, we will also compare the genetic profile that is dominant at a particular point in time to those of ground control plants. We intend to profile the RNA, ribonucleic acid, after harvest and compare this to ground studies so that we can assess if different enzymes or compounds such as glucose synolates, for which radishes and other Brassicaceae are known for, are expressed. This is a brief summary of the science that we hope to accomplish with the radish experiment.
Thank you. If reporters would like to ask a question for Carl or David, please press *1 on your phone. Again, the operator will announce to you and open and close your mic for you to ask your question, and please stick to one question. If we have time, we'll allow reporters to ask a second question. All right, we'll take our first question.
Our first now is from Marcia Dunn with Associated Press, and your line is open.
Yes, hello, thank you. How many radish plants are going up, and will the astronauts be able to sample some of the radishes?
We intend to grow a total of 20 radishes, and so there will be a chance to have the astronauts sample them. However, the detail still needs to be worked out. But I certainly hope that they can sample the radishes and then provide answers as to the flavor of whatever they eat.
And Marcia, this is Dave. I might add that it's 20 radishes, but then we're going to grow two consecutive grow-outs, so there'll be a total of 40 between the two grow-outs.
Thank you. Right, we're going to move to our next speaker. Next, we will hear from Yusuf Erkul. Dr. Erkul is the co-founder and CEO of Kernel Biologics, a Cambridge-based biotech company developing next-generation messenger RNAs for cancer immunotherapy. Previously, he's worked at Merck's Oncology Department, where his research resulted in an FDA-approved cancer drug. Dr. Arkul, please tell us more about the research you have heading up the station.
Thank you, Catherine. At Kernel Bio, we create messenger RNA therapies that instruct specific cells in the body on how to make their own drugs. Our messenger RNA drugs for cancer are designed to specifically kill cancer cells while sparing normal healthy tissues. This cancer cell selectivity is of utmost importance to us, and we achieve this selectivity by taking advantage of cancer cell ribosomes. These are tiny machinery found in our cells that are responsible for reading the message in these genetic messenger RNA-based drugs. We've discovered at Kernel that cancer cell ribosomes are using completely different language, a foreign language that our normal cells don't use, and we can encrypt the messenger RNAs in that foreign language so that only cancer cells can understand this message. Previous investigations on crew members, on astronauts, have shown that astronauts do not have higher cancer incidence despite being exposed to higher ionizing radiation, which is normally a known risk factor for higher cancer incidence. In addition, recent studies also suggest that ribosomes, these tiny little machinery that read the messenger RNAs, are also significantly altered in microgravity. So with this upcoming study on NG-14 mission, we plan to test our cancer cell-specific messenger RNAs under microgravity with the ultimate goal of developing better, safer, more effective messenger RNA immunotherapy for cancer patients. Kernel is a member of MIT Startup Exchange, and we won Technology in Space Prize from ISS National Labs and Boeing through Mass Challenge Boston. This past summer, Kernel also was selected to Y Combinator and received 2 consecutive Golden Ticket Awards from the biotech giant Amgen. Together with these great organizations, we look forward to developing better cancer medicine for patients who urgently need them.
All right, thank you. We'll now go to reporters for questions. Again, please press *1 on your phone to be entered into the queue. Dr. Arkul, can you tell us a bit more about the next steps in your research after this experiment?
Absolutely. We've done a number of tests here on Earth, in vitro and in vivo tests, suggesting that these are our terminology for using petri dishes to grow cells in culture and test our drugs on cells. We've also done a number of tests with mice and with rats. These are animal models that we typically use for preclinical development. We will perform additional late-stage preclinical experiments on our drug candidates for cancer. And our ultimate goal is to actually bring these medicines to the clinic in about 18 months so that we can start testing them on cancer patients. The therapies that we are currently working on take advantage of this novel biology that we've uncovered here at Kernel, but they also rely upon our immune system to really fight against tumor cells in the body and result in durable immune responses that can protect patients also from relapses and recurrences. Immunotherapy really has shown great advances in cancer therapy. It has been able to provide durable, complete remissions in the clinic, and we're building upon our previous experience in this field to develop even better medicine than what is currently available out there.
Thank you very much.
Absolutely.
All right, we're going to go on to our next speaker. Next up are Jim Fuller and Melissa McKinley. Jim is with Collins Aerospace and is the program manager for the Universal Waste Management System, also called the UWMS. Melissa is with NASA's Advanced Exploration Systems and is the project manager for the Universal Waste Management System. The system is designed to be a compact and reliable space toilet that will be used on the space station and on the Artemis II mission. And now they will tell us more about how the system will work in space. Melissa, we'll start with you.
Thank you. As you said, our project provides 2 toilets, Universal Waste Management Systems, for use on the International Space Station and later for use on the Artemis II Orion flight.
It also includes a set of integration hardware for installation onto the International Space Station, basically the plumbing that allows the toilet to be hooked up to the onboard ISS systems. And we'll be doing a test on the ISS to see how the toilet performs in the microgravity spacecraft environment, which will help inform later use on Orion and also for exploration use later on. The toilet was designed for exploration, and it builds on previous spaceflight toilet designs. And the big key to the exploration piece of the design is looking to optimize mass, volume, and power usage, which are all very important components of a spacecraft design. You can imagine that optimizing those can help out in lots of ways because space and power are at a premium on a spacecraft. The new design, the UWMS, is 65% smaller and 40% lighter than the toilet currently in use on the space station, and will be installed just adjacent to that current toilet in Node 3 of the space station. Another big part of our project was optimizing the use of the toilet for the female crew. NASA spent a lot of time working with the crew members and doing evaluations to improve the use of the commode seat and the urine funnel to make it more accommodating to the use by female crew members. The toilet design, as you can imagine, is more difficult to do for a microgravity environment. There is no gravity, which aids in the use of your toilet here on the ground. Without gravity, you don't have a lot of help to collect the urine and the fecal material. So that plus the treatment, the pre-treat solution, the thing that you need to treat the urine with, which is very acidic, those things make the design very difficult. And Jimmy's going to talk a little bit about what they did to work within those constraints to build the toilet.
Thank you, Melissa. So as Melissa mentioned, one of the biggest challenges that the toilet had is to be able to pre-treat the urine before it goes to the urine processor assembly, which is the subsystem that takes the urine and then reclaims the water. So the acid that we use as the pre-treat is very strong. It's so strong that there's only a handful of metals that NASA is aware of that can hold up to this pre-treat over an extended period of time. Those metals tend to be Inconel, alloy, and we found out that titanium works. So obviously, things that are heavy, such as Inconel and alloy, that's bad for space flight, right? If it weighs more, then it costs more to get it up into orbit. So we started looking at things like titanium, and we actually implemented a new process for NASA. It's called electron beam powder bed fusion. That really is just a fancy term for saying that we did additive manufacturing or 3D printed a titanium part. So we basically take titanium powder and use an electron beam, and we basically weld this part and build it up, 3D print it. We actually use that technology on our dual fan separator. The dual fan separator is really the heart of the UWMS. As Melissa mentioned, on Earth, we have gravity that helps pull the feces and urine away from our body and into the toilet. In space, where we have microgravity, we don't have that luxury. So this dual fan separator actually creates the motive force by creating a strong airflow that helps pull the urine and feces away from the body. We're really excited about this new toilet. It's one of the, I don't think we've developed a new toilet in a couple decades. So we're really excited about flying this on NG-14. And, you know, when the astronauts have to go, we want to allow them to boldly go.
Love that. Thank you. All right. Again, please press *1 to be entered into the queue each time. Operator, we'll go ahead and we'll take our first question.
So our question now is from Chelsea Gold with Space.com. Your line is open.
Great. Thank you so much for letting me ask this question. I'm curious about this new cost, and because I know the public is really excited about it because, as you said, there hasn't been a new space toilet in a long time. If there will be any kind of public interaction in terms of naming the space toilet.
I'm not currently aware of anything, but that's certainly a good suggestion, and we'll take a look at that.
Thank you. And Chelsea, I think you broke up a little bit on the first part of that question. So if we didn't completely answer that, go ahead and press *1 again, and we'll get you back in the queue. We'll take a question from social media next.
Hi, I have a question from social. The question is, how will you manage the toilet sewage system on the station?
The toilet will become part of the onboard systems used routinely by the crew. We will be doing a technology demonstration for the first 3 months or so to collect data for the experiment itself. But then the ISS will be doing a much longer demonstration over 3 years, and it will become a normal part of the crew's use, just like the current toilet. And we would ask them to use it more frequently in the first part of the usage so we can get data, but after that it will become part of the normal systems. Is that your question?
Yes, thank you so much.
Thank you. All right, operator, we'll go to our next question from the phone line.
Thank you. Chelsea with Space.com. Your line is open again. Thank you.
Hi, thanks so much. Up before. The other part of my question was, I'm curious, what is the cost of the space toilet? And also, what specific alterations were made to better accommodate female crew members?
Cost information we don't usually talk about in a public forum, but it is available online if you want to look that up. I think all contract information is publicly available. And for the female crew, obviously, when the female crew have a different challenge, especially during urination, and the funnel design was completely recontoured to better accommodate the female anatomy. And particularly, this is a concern when the crew members are trying to do dual ops, when they're doing both defecation and urination at the same time. Just the alignment of all of that at once is a lot. And trying to make that more appropriate for the female use was a big driver. So the funnel shape, the length, the position, the location adjacent to the UWMS, all of those things were factors in that funnel design. The seat was likewise optimized to improve the positioning, to allow the female crew to better align both of those at the same time. So mostly dimensions, orientation, and positioning were optimized.
Thank you. All right, operator, we'll take our next question from the phone.
Marcia Dunn with Associated Press, your line is now open.
Yes, thank you. If I were to look at this new toilet, how big would it be in terms of comparing it to a toilet in my bathroom per se, or something like that? And you made the improvements to better accommodate women. What other features have you incorporated to perhaps keep it cleaner or quieter? Thank you.
I would say the size is very comparable to a compact toilet, maybe something similar to what you might see in a camper. It's a little bit smaller than a normal installation in your home. It's a little bit shorter. But of course, the positioning is very different. I mean, the crew doesn't sit on the toilet. They dock adjacent to it. So the dimensions are not driven by the same anatomy dimensions as they would be here on the ground, but very similar in size. Jimmy, do you have the overall height dimension you could provide?
Yeah, I want to say it was about 28 inches. So it is a lot shorter, but we don't have a septic tank on the water container tank that's used to flush a toilet. So that's actually a big portion or the size of your home toilet. So yeah, about 28 inches tall. The main cylinder.
And other things that we improved the design on is that you don't need to turn on a switch to turn on the toilet. When they lift the commode lid, which is very similar to your home toilet, the unit automatically comes on, the fan comes on, and it's ready for use. And then similarly, when you want to begin urination and you remove the urine funnel that I talked about from the cradle, that starts the unit. So it's an automatically starting system, so you're not having to flip a switch to turn it on.
Thank you. We'll take our next question from the phone, please.
Thank you. Gina Sinceri with ABC News. Your line is open.
So what was the primary factor in designing a new toilet? What was the driving force on this?
Obviously, for exploration, we're looking to optimize anything that we can to keep not just cost, obviously, but usability as improved as possible. The toilet on the WHC currently looks small. If you see the pictures in the videos where it looks like a small unit. But what that doesn't account for is all of the support equipment, the separators, the fans, all the plumbing, because all of that is behind the rack face. So you're not seeing how big that unit really is. If you look at pictures from the shuttle, the EDO version of the toilet, it's a very large cube of equipment that does essentially the same functions that this much more compact and streamlined version does. So the main goal was to reduce those things like mass and volume and power usage and to try to keep those things as minimal as possible so that they take up less space in the spacecraft. They take less propellant to launch the spacecraft because it's lighter. They use less power, all of those things in trying to optimize it for the spacecraft.
Thank you. We'll take our next question, please.
Now, Bill Harwood with CBS News. Your line is open, sir.
Thank you very much. Can you tell us how you all tested this thing? I mean, back in the old days with shuttle, I know they did test on the zero-G airplane. Did you guys do stuff like that? I assume with volunteers? Thanks.
We did not do any zero-G testing of the UWMS. We did a lot of environmental testing at Johnson Space Center where we tested for the extreme environment of spacecraft. And I want to let Jimmy talk a little bit about the special fixture that they built to look at just that testing.
Yeah, well, one thing that I'd like to add before I got into the fixture is that Collins Aerospace has actually done a lot of work on the shuttle extended duration orbiter toilet also. So they took a lot of their historical heritage knowledge and built that into this unit. So while we didn't get to have some fun on the microgravity or the Vomit Comet, we built on the knowledge that we already had. So we did have a fixture that we had to design, and it kind of gimbals the unit. So obviously, if we're testing in a 1G environment, if I pour water into the system to simulate urine, it obviously just goes down to the bottom of the bowl. So we built a device that actually bolts in the UWMS, and it lets you orientate it into different positions, on its side, upside down, and things like that. So we could run the system to challenge it to see how well we could spin a two-phase flow that's, a urine and air simulation mixture and still be able to separate it and, send the urine one way and then recycle the air back out into the cabin. So.
Thank you. We'll take one more question from the phone line.
Our last then is from Irene Klotz with Aviation Week. Ma'am, your line is open.
Thanks very much. I have two questions. The first is there anything in this new system that will help close the loop as far as the life support systems, the water recovery, the waste recovery? And then just a comment, with all due respect, a public forum like this is exactly the place to discuss public financing of public programs. So I would encourage you to release the info now if you have it. Thank you.
So the first part of your question on closing the loop, the UWMS is used in two different ways in reference to that. So for the International Space Station, UWMS doesn't store urine or do any of the regenerative actions, but it collects it and sends it downstream for the ISS systems that are on board that do exactly that. So although it's not directly closing the loop or helping with that, it is a big part of collecting the urine. And a major feature of UWMS, and it's related to the stuff that Jimmy talked about on the separator, is keeping the dissolved oxygen or the air bubbles in that urine stream at a very, very low level so that it doesn't damage that downstream equipment. So having the equipment within the toilet to not only collect the urine and pump it out, but also maintain an air-free flow so that can be incorporated into those regenerative systems. It was a big part of the design. As far as the cost, I guess I didn't mean to say that those weren't available publicly. They certainly are. They're available on some of the contract websites. So it's certainly available to you. I just didn't want to speak about it in this forum.
All right, thank you. We're going to move to our next speakers. Next, we will hear from Carlos Cabrera and Camila Morales Neves from the University of Puerto Rico at Rio Piedras in San Juan. Carlos is a professor of chemistry, and Camila is a chemistry PhD student working on the ammonia electro-oxidation investigation, which studies a potential innovative water recovery system. Camila, please tell us more about your research.
So I've been working, and first of all, thank you for the forum, for the opportunity. So I've been working with the project almost 3 years, and the purpose of the project is to improve the water processing system and to identify new technologies for long-term missions. As it mentions before, the water processing system is very complex, so NASA is trying to identify new strategies to attain some difficult problems. So within the waste produced, as mentioned before, is the urine. And after some processes from the urine, we can have ammonia. So this is the part where our project is focused. So the project is intended to break down the ammonia to a simpler components. So this process is called oxidation. During the oxidation, the ammonia loses electrons, and these electrons can be used to produce electric current. So in summary, this technology has the potential to selectively convert waste to energy. So in this process, like here on Earth, that as I mentioned before, we have the power of buoyancy. So when a oxidizing reaction occurs, where the bubbles goes up here on Earth, but when there's no gravity, this is a complex reaction. So we were trying to describe and mitigate some processes and that comes up with the oxidation of ammonia. So we want to describe it for a fuel cell for long-term missions, and therefore we can recycle this waste and also take some energy.
Thank you. And again, please press *1 to be entered into the queue each time.
Okay.
Camila, what sort of challenges have you faced in getting this payload ready for launch?
The biggest challenge was to miniaturize the system, the lab, because previously we performed some parabolic flights here in NASA. So there was a really big equipment, is like the size of reach of the refrigerator. So my work was to miniaturize this whole equipment to the size of a shoebox, a 2U from NanoRack. So it was really small equipment.
Thank you. All right, now we're going to go to our next set of speakers. Now we go to Felix Lejeunesse and Paul Raphael. They are the co-founders and creative directors of Felix and Paul Studios, and Jonathan Woods, executive producer for Time. Jonathan is responsible for all photo and video at Time, including a team of over 30 visual journalists, producers, and editors around the world. The ISS Experience EVA camera will be used to film a spacewalk and Earth views in cinematic 360-degree virtual reality. Felix, will you please start us off?
Absolutely. So I am the co-founder and creative director at Felix and Paul Studios. So for more than a year and a half now, we've been filming aboard the ISS, a cinematic virtual reality series about life in space. It is called Space Explorers, the ISS Experience. It's a co-production between Felix and Paul Studios and Time, and it's going to be the most immersive media experience about life in space ever produced. So that series is filmed with stereoscopic 360 cameras that have been designed especially to film inside of the space station. And those IVA cameras have been sent to the ISS about 2 years ago in December 2018. So we've been in production for 2 years. Now we are launching on NG-14 a new cinematic virtual reality camera to space, but this time it is designed to film outside of the space station in the vacuum of space to capture the first ever spacewalk in cinematic virtual reality. So this new EVA VR camera is going to be taken out of the ISS. It will be installed on Canadarm2 so that we can move the camera around the station to get extraordinary shots. We will film a full spacewalk activity from the moment the astronauts come out of the station to the moment that they go back in, and audiences will feel like they are truly there, up there, floating in the vacuum of space alongside the astronauts. Then the camera is going to spend a few additional days outside of the ISS so that we can film additional beauty shots of planet Earth and exterior shots of the station as well. And once that filming outside of the space station is over, that is going to conclude principal photography for Space Explorers, the ISS Experience. So that's a quick overview. I'll leave it to Jonathan.
Thank you, Felix. It's great to talk to you all today. Thank you for joining. I've been working as a journalist for 15 years, and I've done some incredibly ambitious projects, and this has shattered every expectation that I've had for anything I've taken on in my professional career. From the outset, this project has been precedent-setting and truly historic in a number of ways. It's been incredible to watch Felix and Paul Studios at every turn, pushing envelopes, challenging conventions, breaking the molds, all of this together with NASA and the international partners that comprise the International Space Station and Time, with the intent of bringing this experience to Earth in a way that's never been seen before. Look, in the 6 decades that we've been able to send humans into space, there's been less than 600 people who have had a chance to witness this perspective of being an astronaut in space. And I think that this project, exemplifies that in our aspirations in the purest senses. And I think finally, Time is a media brand. We've been covering space and the global space race in all of its forms since its genesis, from the early days of Time and Life magazine and, Ralph Morris, who's endearingly referred to as the 13th astronaut. We've always sort of held center to our culture the importance of these missions, the human ambition, and the unique ability for us to capture it in new and interesting ways. And anyway, Paul, I think you'd like to talk about some of the technology you guys have been bringing to the table, so I'll stop talking. Thank you.
Sure. So just a few words about the technology behind this. So just like what we've been shooting, IVA, we're using an 8K 3D 360 camera, so that's 8K per eye, so very high quality. It's an adaptation of the Zcam V1 Pro, which is a commercial camera that we adapted. We did this in partnership with NanoRacks, who has a long history with NASA. They're specialized in microsatellite deployment. They helped us design the enclosure to help the camera keep cool and warm, basically, for the extreme temperature variations, protected from vacuum. We went through the whole certification process, and like Felix said, we'll be using the Canadarm2 as a celestial crane, much like you would on a film. We also had to make sure the camera could handle extreme shifts in dynamic range. There's 16 sunrises and sunsets in a day, and we have to be able to adapt to the fast-changing light conditions. We also had to make sure that communication was robust. We will not have constant access to Wi-Fi. I just wanted to say that actually just before getting on this call, I saw a near final version of the first episode, and I literally had chills watching it. And I think everyone involved did an incredible job. And I'm now more than ever convinced that VR will eventually become the default way to document space exploration from a storytelling standpoint, but also from an operational and situational awareness standpoint. So I think I speak from the entire team when I say that we're beyond excited to get this series out into the world.
Thank you. We'll now take questions for Felix or Paul or Jonathan. Again, please press star 1 to be entered into the queue. We'll go ahead and we'll take our first question from the phone line.
Thank you. Our question now is from Jeff Faust with Space News. Sir, your line is open.
Great. Thanks. This looks like an interesting project. When are people going to be able to experience this footage that you've collected and will be collected with the new camera? And is this being done through the ISS National Lab or through the new commercial allocation for ISS activities? Thanks.
Yes, this is Felix. So it is done through the ISS National Lab, and in terms of the launch and distribution, so the first episode of the series will launch at the end of October 2020, so in about 1 month, in virtual reality, and it's also going to launch simultaneously as 5G-enabled 360 video content for smartphones and tablets through a telco alliance, so it's going to be launched internationally. And then the subsequent episodes, both for virtual reality and 5G 360 video distribution, are going to be launched once every quarter in 2021.
Thank you. We'll take our next question from the phone, please.
Thank you. Marcia Dunn with Associated Press. Ma'am, your line is now open.
Yes, thank you. It sounds like the astronauts will have to take time out of their spacewalking work to actually do the filming themselves, or do you anchor the camera outside and just hope they pass into the sight of line? And if they are handling this camera outside, how difficult will that be for them in their gloves, et cetera? Thank you.
Yes, this is Felix again. So basically, the camera is going to be prepared inside of the space station, going to come out through the GEM airlock, and it's going to be picked up by the Canadian arm. And the idea is that during the production, the astronauts are not going to have to handle the camera. It's actually all going to be operated from a distance because the camera is going to be rigged on Canadarm2. So all the operations of moving the arm are going to be done by the NASA robo team working with the Felix and Paul Studios team and the NanoRacks team. And so everything is going to be done remotely, and the astronauts won't have to actually worry about the camera. And generally what we will do is we will bring the camera relatively close to the work sites at a distance of about 6, sometimes 7 feet from the astronaut, so that once you're immersed in virtual reality, you feel like you are right there with them. You feel like you are a participant in the action.
Marshall, one follow-up to that too. Hey, it's Jonathan Woods from Time. We're also going to be producing a simulcast of this event so that folks that are on the ground can actually see this happening during the EVA event itself. And the brilliance of watching Felix and Paul Studios and their producers script out how they want to storyboard how astronauts experience EVAs truly is going to be as close as we can ever get to a one-to-one experience of what it's like to be an astronaut outside on a spacewalk.
Great, thank you. We'll move on to our next speakers. We'll now transition from the science and research to the business and commercial activity actively enabled by this launch. To talk about our final payload on this call, we have Phil McAllister and Stéphane de la Faverie. Phil is the Director of Commercial Spaceflight at NASA. Mr. McAllister has been working at NASA headquarters for more than 15 years, the last 10 of which has been overseeing the commercial crew and commercial cargo programs. Prior to that, McAllister worked in industry and commercial space and satellite ventures. Stéphane is the Group President of Estée Lauder Companies and the Global Brand President at Estée Lauder. Estée Lauder is the flagship brand of the Estée Lauder Companies. Founded by Estee Lauder, one of the world's first entrepreneurs, the brand is now found in over 150 countries and territories around the world. They will discuss plans to photograph the company's new advanced night repair serum in the space station's iconic cupola window as part of NASA's efforts to enable business activities at the space station and develop a robust low Earth orbit economy. Bill, can you please start us off?
Yeah, thanks, Stephanie. I'm going to let Stefan talk about the particulars of their activity, but I wanted to describe how these types of activities, like the Estee Lauder payload, support NASA's overall commercial space endeavors. I know there were probably some people that were surprised when they heard NASA was supporting a marketing initiative on the ISS, and that's exactly why we think this is a good project to perform on the ISS. We need to expand people's perspective on what we can accomplish in space on the ISS. If you think about it, the ISS, I mean, it's really been an incredible resource for the United States and the world, really, but it's not possible for the ISS to operate indefinitely. There is going to be a time when the ISS is retired. And at that time, NASA intends to transition to commercial space destinations in low Earth orbit for NASA's ongoing needs. And in order for those destinations to be sustainable, they're going to need customers other than NASA to support their operation. This Estee Lauder payload is one part of NASA's overall strategy to help making that transition and to help commercial LEO development. Last year, in June of 2019, we announced our plans to expand the scope of activities that can be performed on the ISS to include business opportunities, and we dedicated a relatively modest amount of NASA's utilization resources, just 5%, to enabling these kinds of activities. U.S. entities can propose activities to be conducted aboard the ISS, but they have to meet one of three criteria. Number one, they have to require the unique environment of microgravity. Number two, have a nexus to the NASA mission. Or number three, support the development of a sustainable low Earth orbit economy. So proposals are reviewed by a team of NASA officials to determine if it meets at least one of the criteria that I mentioned and are consistent with NASA's other policies and regulations. And the Estee Lauder proposal was determined to meet criteria number three. And the Estee Lauder will reimburse NASA approximately $128,000 for the NASA resources associated with conducting this activity. So we really believe this type of activity can help catalyze and expand space exploration markets for many businesses by demonstrating the value of conducting commercial activities in space. In order to transition to commercial space destinations, we need many businesses thinking of unique and innovative ways to expand the economic activity in space. We also think there's value from a large, well-known company such as Estee Lauder being among the first companies to take advantage of our commercial use policy. And we really hope that this will increase awareness of these opportunities among the commercial community. And again, if we're successful, then NASA is going to be one of many customers for commercial space destinations, and that will not only expand commercial opportunities, but it should lower NASA's costs for microgravity services. And I really want to commend Estee Lauder for sort of thinking outside the box and thinking of a unique application of the ISS in space, and we hope to see many other businesses to follow. We don't know exactly how this is going to play out, but we do know that this can be a part of our strategy with helping raise awareness. We need lots of people thinking of different things to do in space, and the fact that this was a surprise to so many people, I think, speaks directly to that point.
So, thank you, Phil, and thank you for this introduction, and thank you for giving us all this detail. But I really want to first thank you, the NASA team, for inviting me to speak at this conference. I'm really thrilled today to be here to represent the Estee Lauder brand alongside such esteemed panelists. You may be asking, why a beauty company is interested in sending our product to the International Space Station. And I think Phil basically said, we need to think outside of the box. But more importantly, it's because the Estee Lauder brand was built on creativity and innovation. Mrs. Estee Lauder, our founder, founded actually the Estee Lauder brand almost 75 years ago and was a woman ahead of her time. She was a visionary and a challenger who proved that anything is possible if you dare to dream it and had the bravery to go after it. And I think this is what we're trying to demonstrate today. We continue to embrace the spirit of creativity and innovation in everything we do. Estée Lauder is one of the leaders in skincare innovation around the world, and we are always looking towards the next frontier of breakthrough. And we are today really incredibly inspired by the work that NASA is doing to push the boundaries of space exploration. And we saw a lot of synergy between both our brands' commitment to science and innovation. As we learn about NASA's goal of helping create a space economy at the International Space Station, we were really excited as a team by the opportunity to work with them as the second ever commercial product to launch into space, and more importantly, the first ever beauty brand. So we have tremendous respect for what NASA does, and we are proud to support his efforts actually to enable a viable low Earth orbit economy. Estée Lauder brand will be sending 10 bottles of our new Advanced Night Repair Serum to the space station on the Cygnus spacecraft, coming soon. We choose this iconic product because of its long history of first in the beauty industry. When it launched in 1982 as Night Repair, it was the first nighttime repair serum in the beauty industry and the first ever beauty product to use hyaluronic acid. Now, 30 years later, we are adding another first to this legacy, and it's now the first serum to launch into space. As mentioned earlier, it will be photographed in the space iconic cupola window to create image that we will be using on our social media platform. This final image will be part of an exciting story that we are building to share with followers as we take them into a journey into space and to reinforce at the same time our leadership in skincare innovation. And one of the other exciting things is when the Advanced Night Repair bottle will return to Earth next spring, we're looking forward to auctioning one of the bottles for charity. So in conclusion, and to the NASA team and to Phil, we really want to thank you for inviting me today to this teleconference, but more importantly, to allowing the Estée Lauder brand to be part of this new commercial venture. We are really proud to be part of this opportunity, which I believe reflects Estée Lauder's commitment to innovation and science and for thinking outside of the box. This type of commercial opportunities help NASA, as mentioned by Phil, to continue their deep space exploration. And we are proud to support this initiative as they push the boundaries of innovation and exploration every day.
Thank you. I will take our first question from the phone, please.
Thank you. Marcia Dunn with Associated Press. Ma'am, your line is now open.
Yes, thank you, sir. I'm not sure if I understood. Did you say 10 bottles of this serum was going up? And is it merely a photo shoot, or will there be any scientific aspect to this regarding the formula or how it might be used in space? And lastly, for Phil, what are the rules for astronauts regarding these sort of marketing attempts in aboard the space station? And do they have to stay out of the camera view, et cetera, et cetera? Thanks.
No, thank you for your question. Actually, to be precise, yes, it is 10 bottles of the Advanced Night Repair Serum that will go into space. And for the time being, it is actually not a photo shoot as a commercial. It is just some pictures that will be taken in the iconic cupola that we'll be using on our social media platform. And that's the pure initiatives that we are working on today with the NASA team.
Yeah, and as far as the second part, Marcia, the rules for the astronauts, they can facilitate the photo shoot, so they can take the pictures as part of their official duties, but they cannot be seen in the shots, and they're not going to receive any additional compensation. Ethics rules bar them from doing that. We're paying their salary. This is part of their normal duties. It's just like I speak at conferences all the time, and some people offer me honorariums, and I sadly cannot accept those as a civil servant because I'm already getting paid. So those are the rules for the astronauts.
Thank you. We have time for one more question. We'll take the next question from the phone, please.
Thank you. Our last then is from Jeff Faust with Space News. Your line is now open.
Question, I think, for Phil. Wonder if you can talk a little bit about what the pipeline of future commercial initiatives on space station looks like. Are we going to see a range of other companies in discussions with you right now to do similar sorts of activities on space station over the next year or two? Is this sort of a pathfinder for that?
Yes, I think it's sort of difficult to say exactly how it's going to play out, Jeff, but I can say that we have several other proposals that have come into NASA and that are currently under evaluation, and we've already signed another agreement that we will be talking about soon. So this is a pathfinder, but I think this has definitely raised awareness, and we're going to see more interest, we hope, in the future. I'm not sure this particular marketing activity, how sustainable it'll be. We'll just have to see, after a bunch of people have done this kind of thing. We'll just have to see. And that's the great beauty of the market, right? You kind of try something out, see what works, see what doesn't work. I don't expect everything that comes through the door to work, even if it gets approved. And again, I really think that's the beauty of commercial initiatives and these kinds of markets that are really just nascent at the moment. All I can say is, for us to get things to work, things have to come to us, and that's why we like this idea. Getting people to think about, how can I use space? I mean, I just Googled it. Marketing is a $43 billion industry. I don't see why there's any reason why that all has to be done terrestrially. A little piece of that could be done in space, and I think that would be a good thing for everybody.
All right, thank you very much. That's all the time that we have, and that concludes our questions for today. Northrop Grumman is targeting Tuesday, September 29th at 10:27 p.m. for the launch of its Cygnus spacecraft on an Antares rocket from the Mid-Atlantic Regional Spaceport's Pad 0A at Wallops Flight Facility on Wallops Island, Virginia. Next week, we'll broadcast more about this mission live on NASA TV beginning Monday, September 28th. Stay tuned on nasa.gov/Northrop Grumman for more details about next week's launch and coverage on NASA TV. And you can follow along with our researchers and these studies as well in orbit online at nasa.gov/station. You can listen to a replay of this teleconference by dialing 800-342-8825. That's 800-342-8825. Thank you for joining us.
Conference is now concluded. Thank you very much. Enjoy the rest of your day, and please disconnect.